Example 4. Option 1, you can have $1,000 a year for 20 years. Option 2, you can get $1 the first year, $2 the second year, $4 the third year, doubling the amount each year for 20 years. Part A, create a function to model each option. Well, first of all, when we start this, I think I'm going to kind of make a table and see what's going on. So option 1, you can have $1,000 a year for 20 years. So if we kind of start a table, we've got years, we've got money, and then first year, second year, third year, fourth year. That's probably good enough. Option 1, we get $1,000 the first year. Then it says we get $1,000 each year. So in year 2, I'm going to get another $1,000, which means now I'm going to have $2,000. Then I'm going to get another $1,000, which means I'm going to have $3,000. And then I'm going to get another $1,000, which means I'm going to have $4,000, etc., etc., etc. Now, what we're getting at here is if you're adding $1,000 each year, this is linear. And linear, so option 1, is y equals mx plus b. That's going to give us y equals m is your slope. So our slope is increase by 1,000, increase by 1,000, increase by 1,000. So 1,000 x plus b is my y-intercept. Now, your y-intercept, if you're looking at a table, is when your table started at 0. And in my table, I didn't really start at 0, so I'd almost have to go backwards here to year 0. Well, if I'm adding 1,000, adding 1,000, adding 1,000, that means I would have to subtract 1,000, which means I started with no money. So on here, we would put plus 0, but you really don't need that, so I'm going to get rid of it. And this would be your equation to model option 1. The way you would test that, let's say we picked year 2. If I were to substitute 2 in here, y equals 1,000 times 2 is $2,000. That's how much money I have in the account. Now, option 2. A little bit more tricky, but we're going to start the same way. And let's take a look at a table. So, year, money, 1, 2, 3, 4. And for option 2, after the first year, we get $1. Then in the second year, we have $2. And then in the third year, we have $4. And then they say we're going to double that each year. So 1 times 2 times 2, that's really what we're doing here. So then this one would be 8, etc., 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 and that's how much money we have. Now, if we're doubling each year, this is exponential. And exponential is y equals a times b to the x power. Except this one's going to be a little funny. So A is going to represent your starting amount or your y-intercept, which here we don't have it, but we really can't go back because if you put 0, you're going to multiply by 0 and that's just going to throw everything off. So we're going to say y equals, and we're going to start with 1 times b is your common ratio, and we're multiplying here by 2 to the x power. Now, if I test this equation, there's going to be a problem. So if I put in 2, I should get out 2. So 2 squared is 4 times 1 is 4. Well, that's not right. That's that one. Okay, what if I put in 3? So 2 to the third power is 8 times 1. Well, that's that one. That's not right either. So really what we're going to do here is I'm going to take that x power and I'm going to subtract 1 and then see what happens. So now if I substitute in 2, 2 minus 1 is 1. 2 to the 1 is 2 times 1 is 2. This is your equation that's going to represent option 2. Part B, after 5 years, which option would give you the most money? Well, we can do that two ways. We can either go look at our tables or we can use our equations. If I look at my tables, I'm going to say, okay, 5 years. Well, 1,000, 2,000, 3,000, 4,000. I'm going to have $5,000. Or down here, I doubled. I'm going to have $16. So after 5 years, I'm going to go with option 1. Because I'm going to have $5,000, not $16. Now, after 15 years, which option would give you the most money? We could keep going on the table, but this is where using a table is going to take too long. So option 1, we have y equals 1,000 x. Well, I want to know after 15 years, so I'm going to substitute in 15, and I'm going to take 1,000 times 15 is going to give me $15,000. Now, option 2, y equals 1 times 2 to the power of 15 minus 1. Now, if I clean that up just a little bit, that's going to be y equals 1 times 2 to the 14th power. So I'm going to take my calculator and substitute that in, which is going to give me $16,384. So after 15 years, which option is going to give me the most money? Option 2. Part D, which option would you ultimately choose and why? Well, it says up here that we're doing this for 20 years. So ultimately, in the long run, I'm going to choose option 2. And the reason is because I'll make more money. Option 1 starts out at a lot more. I make 1,000, 2,000, 3,000 versus 1, 2, 4, or 8. But in the long run, after 15 years, here I'm making 15,000. Here I'm making 16,000. So the longer I go, if I double 16,000, that's $32,000. Versus over here, I would just add another 1,000, which is 16. So in the long run, ultimately, I'm going to choose option 2. I'm going to make more money because it's exponential growth. And exponential growth eventually is always faster or more than linear.